Well, ladies and gentlemen, our next topic, decoding fashion contexts using word embeddings. And Deepak and Sagar will tell us how. Could you please come up on stage? Ladies and gentlemen, put your hands together and welcome on stage Deepak and Sagar.
Hello everybody. Yeah. So just a quick introduction. I head the data sciences for Myntra, and I'm assuming everybody's aware of Myntra. It's a fashion e-commerce, right? And what we'll talk about is a fundamental problem in fashion. And this is a work which it's a joint work with Sagar. So half of the discussion will be led by Sagar, and I'll just introduce the motivation and the thought process behind this problem and how we kind of approach the problem, right? And as I mentioned, it's a fundamental problem. And I'll just get directly into it. I think the gist is motivated by this question, right? Is B similar to A, or is C more similar to A, right? That's a fundamental question. And I think to give it more specific in a e-commerce setting, if A goes out of stock, would I suggest B to the user, or should I suggest C to the user? And that's a fundamental question which we're trying to answer, and it captures pretty much the main insights behind and the main contributions of this work, right? So, and the answer is, look, depends on the context, right? If the person is looking very specific for a functional running need, right? A and C have that cleats, right? They are basically running shoes, right? And hence, maybe C is what I would recommend to the user, right? Let me get used to, I should be looking at this rather looking at the screen. So yeah, if the person is looking for a functional need, right? He's looking for a running shoes, then I should probably recommend C to the user. But maybe if it's just a casual user who's just looking for the visually appealing shoe, then maybe B is what should be recommended, right? In the interest of those who came just a few minutes late, I'll just summarize. Talking about decoding fashion context, I head data sciences for Myntra. It's a work, and I think this slide pretty much summarizes the main insights and the main contributions behind the paper. And the question posed is, if A goes out of stock, the Adidas shoe goes out of stock, should I recommend B to the user, or should I recommend C to the user? And the answer I was saying is, look, it depends on the context. If the user is looking for a functional running serving a shoe which helps him in running, then I think C is what is probably more similar to the product A, right? And but on the other hand, if it's just a casual browser who's just probably doesn't understand too much about running shoes and he's just looking at the visual appeal of a shoe, then I think it is B, which is probably a right recommendation to the user. Now, product similarity is a very fundamental problem in all e-commerce companies, right? And fashion makes it a little bit more hard because I think it has some amount of a little heavier semantics in some sense, right? And I'll get to those aspects. Now, if I think about it, I think the two points which come out of this problem. One, product A serves maybe multiple contexts, right? So a product can actually cater to multiple needs. So product A, for example, serves the running need of a person, or it probably serves a casual look and feel of a person, right? The other important problem, right? If I do just a visual similarity, like we are talking about computer vision, we are talking about multimodal representations, why do we think about all of that? And why does text and textual attributes and visual attributes are both important, right? If it's just a computer vision problem, I think A is similar to B, right? That's what a typical image processing would do till it figures out, what is more important, right? And that brings to the second problem. When you have two attributes, which one is more important? Is cleats more important than the color? Right? How do you answer that question? That's again a fundamental problem in product similarity. Which attributes are more similar? Who tells you which is more similar, right? So two problems. One, what is the definition of similarity? Second problem is a style can be serving multiple needs. So there need not be one definition of similarity. So the fundamental problem is multiple hypotheses on similarity, depending on the user context, right? And that is the problem we want to solve, right? And that's a fundamental problem of fashion e-commerce and any e-commerce in that point, right? So then how do you go about it, right? I know there are multiple contexts, and one way to do it is, so how can we infer the consumer context? And this is where, some amount of user signals can be helpful, right? If I can get a little bit of information from the user, then it becomes an easier problem, right? But till we get into till the interfaces improve where you can do explicit question answering or explicit conversation, we're still far away, right? So in absence of that, how do we kind of answer this question, right? And that's where, looking at the session in how the user has arrived at the product is helpful. So if I look at the user session, then maybe that gives us some signals, right? The product's context can be extracted from the user sessions. So if I look at all the styles which he has browsed, and all of them are cleats, then I know B is the product to be recommended, right? If A goes out of stock, I can recommend a running shoes, because if I looked at all his session, and his session assuming is cohesive, and he's looking at all running shoes, then I know B is more similar, right? On the other hand, if the session looks like this, there is no particular signal about cleats or running, then I would assume, look, C is a better, right? The color is the main attribute which defines similarity and not so much spikes, right? I think this is the fundamental problem and the answer. So I put forth the problem, and I've also given you the answer. Like the attribute similarity can be extracted from the user session, and by looking at the user session, I can define which attributes are similar and use that notion to render the recommendation, right? So that pretty much that's the problem and the solution, and what we'll talk next is how we kind of actually execute that, right? And so this work originally obviously started in context of personalization. Personalization, is key for e-commerce, and for that matter, any internet, company, it's an important point, right? The two main reasons: one, it caters, because online you're able to cater to a wider and a diverse consumer need, right? Unlike a typical offline setting, right, which probably caters only to that particular geography, right? Online you're able to kind of cater to a wider need, right? And the other thing, for a long time, we were a mobile-only kind of a company, and so then the ratio of real estate to the products is overwhelming. Just to give you an idea, like how important personalization is, like, right, if you take an example of this conference itself, right, there are only probably 1,000-odd companies and 1,000-odd people, and probably everybody has different expectation. But I can only serve one content, right? So, and I might be wasting some people's time, and I'm probably addressing somebody's expectations. An ideal setting is personalization, where you really go just consume only what you're interested in. Right? And think of it a much more larger scale problem. You have 15 million users, you have 3 million products, you have very small real estate. The only way to really serve that is through personalization. Just show what is relevant for the user. So personalization is critical. Now, the accompanying problem is, it's not easy, right? You really need to detect the context to render personalization. And fashion makes it a little bit more hard because of this particular problem. One style can serve multiple contexts. When a person is coming to browsing a shirt, he's not telling you what look he has in his mind. So all apparels are part of a look which the user has in mind. So if he's looking at a t-shirt, he might be thinking, okay, I'm going to pair it with the jeans I bought recently, or it's just a blue t-shirt. I don't have a blue t-shirt in my collection, so he's just looking for a blue look, or it could be just something else, right? So a product is part of a larger look which the user has in mind, and he's not communicating it to you. So that semantics of fashion is what makes it a little bit more challenging, and detecting context, it becomes harder, and which means rendering personalization is much, much more harder, right? So then the objective of the work is, look, we need to decode fashion context so that we're able to understand the need. And if I'm able to do that successfully, I might do a good job in personalization. Ultimately, we want to do a good job in personalization, right? So when you go about started solving this problem, I think just, how does other domains do it, right? What are the similarities? How can I compare, contrast fashion with other domains? I think where the domains where personalization has worked very well, recommendation systems have worked very well. I think the examples are Netflix. For movies, you had Hunch, and before Hunch got bought by eBay, and there is Pandora Box, Spotify. Musics, movie, books, they've done a good job about recommendation, right? But fashion has some elements similar. I think the main thing is there's a heavy notion of personal taste. I do like certain kind of apparels. No matter what you do, I'll never wear a slim fit jeans, right? I have a very strong fashion taste, right? And there's an element of social proofing as well. You do like to kind of review what you bought with your, partner or who, so there's an element of personal taste and social proofing, which makes it fashion similar to other domains, like books, music. There's a very fundamental difference though. Books, movies have a very long life, right? It's not, unlike that, styles are ephemeral and fast changing. Your typical style lasts not more than, 2 months, right, in a catalog. So getting a signal, a sustainable signal is that much more hard, right? I can get a signal about a movie across years, across diversity of consumers, right? So I'm able to get the signals much, sustainable signals, right? That is not available, right? And the last point is, look, this element of multiple contexts, a style can emerge in multiple contexts, serving multiple looks, right? I think that is also a point why fashion is different from other domains, right? So then what are the challenges? One, again, the other one element of challenge is there's not a very rich uniform taxonomy, right? It's very difficult to nail down all the attributes of a product, right? We don't go, and it's not uniform across brands. People use different taxonomy. So that's one challenge. How do you kind of circumvent that problem, right? The lack of a rich uniform taxonomy. Styles are ephemeral. That means, you can't build a sustained signal. So you want to work at, there's t-shirts, and then it drops to, the SKUs, right? There's nothing in between which is saying, look, a richer definition of a collection of products, right? If I'm able to do that, I could operate at that atomic unit. That is missing, right? And the other challenge is, yes, the user intent may not be clear. Ultimately, the answer we propose is, the sessions might give us signals, and we could use that. And we need to establish style similarity with respect to specific context. So those are the kind of challenges. How do we go about addressing that is the rest of the talk. And so as I mentioned, product similarity is the fundamental problem we are trying to solve in the context of online fashion, e-commerce, right? What have been the typical approaches of similarity, product similarity, and what are the pluses and minuses, right? The two main approaches people use, right? One is a attribute-based similarity. What is the positiveness, what is the plus point in terms of fashion, in terms of fashion products? By looking at attributes, I'm suddenly decomposing styles into the attribute space, and so I'm not worried about the short life of style anymore. I can translate all my inference in terms of attributes. So I can say, look, the color is what is trending, it's the stripes what are trending, and so on and so forth, right? So the cold start problem, which typically happens when a new style enters a recommendation system, that can be circumvented if you use a attribute-based approach. What are the negatives? Ultimately, it's an attribute similarity, right? Or the point which I raised earlier, who defines what is more important? Is color more important in a polo, or in a t-shirt, or is the stripes more important? At best, you can go to a subject matter expert, you can talk to a fashion stylist, and that is just one point of view, which probably won't address the diversity in an e-commerce setting, right? You have n number of diverse customers, right? So then the choice of weightage weights of attributes is not clear. And then the little bit more tactical, eventually styles, typical approaches, you kind of cluster them, styles are forced into one group, so I lose this essence of one style being part of multiple groups, which is an ask we had from when we started this work, right? And obviously there's no notion of user context. We kind of left all the information which sessions give us, right? We kind of discarded all of that. We relied just on the style description in terms of attributes, right? The other approach which people take is the collaborative filtering using user signals, right? What have similar users browsed, and using that I can define some notion of similarity. So there's some notion of user context. However, what the typical approach is, you do a item similarity and you start again doing clustering. You don't get this notion of one style being able to serve multiple contexts, right? And that's essence is a big problem. And there's still the cold start problem. If a new style comes, how do I recommend it to a user? What is the basis of recommendation? Because I have not observed a session yet, right? I have not observed that styles proposition yet. So in that context, I think the motivation is, can I club these two approaches? There are pluses in both, there are minuses. Can I club the two approaches together and come up with some solution, right? So the approach which we propose is tries to marry the two approaches, use session data for context extraction, and still work in an attribute space so that the longevity of inferences can be managed, right? And so where did we draw the inspiration? I think the inspiration was from natural languages. If you look at natural languages, there's some similar challenges. words emerge in multiple contexts, right? Words are substitutable only in specific context, right? You cannot use the same words which might in different contexts, right? And the taxonomy problem has been, as you know, is there in the NLP, right? People used to write manually, encode the whole taxonomy. WordNet is a classic example. For a really long time, all NLP approaches heavily relied on WordNet. What we quickly realized that as the vocabulary space is growing using Twitter, the number of words emerging is going faster, and this taxonomy approach is not going to scale. We need to come up with a different approach, right? And what did they rely on? Which is all the deep learning is about. You decode the context of a word from its usage. So you said, look, I'm not going to create a taxonomy. I'll just throw a huge corpus of documents into this tool, and it'll decode the context looking at the usage. And the classic cliched sentence is, you shall know a word by the company it keeps, right? That's what NLP talks about, right? And so using a large corpus, you're trying to extract you translate into a semantic space where these words are similar. Right? Basic how they're used, how they co-occur in documents. So that's the approach they take, which is very similar to what we're trying to do, right? What is the scale? We have millions and trillions of sessions. So that is our corpus. We have huge corpus of data, right? So our sessions are document, and that's a fundamental contribution. We look at each session as a document, and we look at the co-occurrence of attributes in a session. And session pretty much captures the user context, right? When a user enters a website, he probably has some need in his mind and is browsing the products with a specific need in his mind. So session captures that context, and we have millions of sessions, which brings it to the scale of what deep learning typically requires. You need a really large corpus to be able to extract those semantic similarities, right? So we rely on sessions. We look at the co-occurrence of attributes in a session and derive that similarity, right? So that's the main inspiration. And I think that brings up to the second part of the paper. I've just kind of laid out the motivation, the thought process behind the approach. And what I'll have Sagar is just explain the approach in more details. And we'll probably take questions at the end of the part.
Right? Thank you, Deepak. So just a quick introduction about myself. I'm Sagar Arora, and I work in the data sciences team at Myntra. So primarily, my work has been focused towards personalization at Myntra. So different users tend to see a different sort order based on how they browse, what their clickstream is, what they purchase with us. So that's the primary work I've been doing at Myntra. So following up on where Deepak left, word is known by the company it keeps, right? So I'll just start off giving you an intuition behind the word-to-vec approach, and we'll probably then tell you the way we use that word-to-vec in our scenario. So for instance, I've just taken these two paragraphs from a recent news article. So consider the word, say, fashion, right? Now, just see the window of the word fashion. Say some 10 to 20 words on the left and 10 to 20 words on the right. So can I probably say that, the probability of the word, say, lifestyle, co-occurring with fashion is quite high? Can a model try to learn that? I mean, it's not just, you might think that why not just have some sort of a co-occurrence counts, and that sort of an approach was, followed till 2005 or 7 or so. You sort of take a document, you take a center word, right, and you find out what are the co-occurrence counts in the neighboring window, and you land up with the metrics of order v square, v cross v sort of a matrix. Now, so again, you have the problems with the storage, then probably, and again, the sparsity issue, right? So then people, tried approaches like SVD and stuff, so tried to, factorize that matrix. But again, can a model try to learn that, see, here it's a node on Flipkart, here it's Binny Bansal, here it's Myntra, and here it's Anand. Can I say that, those two vectors are, parallel to each other? So can a model try to learn that? Or can a model try to learn that, for instance, I have Flipkart, so what Myntra is to Flipkart, Jabong is to Myntra. So can a model, try to learn all that stuff? So that's the main intuition behind word-to-vec. You take a center word, right, and you sort of try to predict the probability of the words which are in the window, which co-occur with that, right? So I'll just show you this sort of a model. So this is, I mean, you can totally ignore the next 5 minutes of the talk, but yes, I'll just show you the model, right? So you have a center word. Now you have this V means the vocabulary size, right? And you sort of learn. So these weights itself are the the embeddings of each of the words, the n-dimensional hidden layer which I have shown, and the C words on the output layer which you see. These are the sort of the context words. Now context words, the words which surround the center word. So that's what I call as a context word. So given a center word, predict the context words. So word to vec is as simple as, I mean, it's very similar to what log regs and stuff is. So take a word and try to maximize the probability of the words in the window co-occurring with the center word, right? So again, I'll just throw up some equations onto you, and that's the only mathematics in this sort of the talk. So just bear with me for next 1 minute or so. So that's what essentially we do. So this j of theta, so that's the function which we need to actually maximize, right? So consider that sentence, I mean the 2 paragraphs which I was showing you from the article. So let the center word be fashion. And I want to maximize the probability of the word, say e-commerce, brand relationship, or customer experience, co-occurring with the word, say fashion, right? So here in the first equation, WT would be the center word, and WT plus J will be the words in the window, and window size in this case, in this equation is M, right? So you take a word, you take M words towards the left, and M words towards the right, and you try to find out the probability of those words given the center word WT. And how do we define that probability? So probability of O given C, O means the outer word and C means the center word, is given by a softmax. So in case you are not aware about the softmax, it essentially means take a real number and squash it into a probability domain, right? So it's intuitively you can just understand it as unnormalized log probability. So consider UO transpose VC as the unnormalized log probability. Hence, e to the power UO transpose VC would be the probability, and then you sum up over all such terms to normalize that. So that's how you intuitively understand what softmax actually is, right? So what's the issue with this? Practically, we actually do not follow the equation which I have shown you, because if you see the denominator, we are summing up for all the words in the vocabulary, which we would rarely do. So updating any single word vector would be computationally quite expensive in such a case. So we follow something of sort of which we call as negative sampling. So essentially what you want to do is you want to maximize the probability of the words co-occurring with the center word in the window, and for the rest of the words you need to minimize the probability. So that's what the third equation essentially would say. So the first term says maximize the probability, and the second term says you P of W means all the rest of the words. So it's the unigram distributions raised to some 3/4, which the authors say in the word to vec paper. But essentially, you need to negatively sample some k words out of the from the unigram distribution, and you sort of try to minimize that sort of the probability, right? So that's all the mathematics part. So if you didn't get what I said in the past, like 5 minutes or so, essentially what we want is the words which occur in similar context should be embedded in the higher dimensional space quite close to each other, right? So that was the entire gist of whatever I've said till now. So quick note, essentially people have tried using this sort of a word-to-vec approach to understand, likes of Stitch Fix and folks from List also have tried this approach, but every time people are using that sort of an approach on a style level. So essentially the context which Deepak was talking about, so that sort of is not really captured when you do that sort of an approach on a style level. So instead of treating style as a document, in this particular approach we consider session as a document, right? And the attributes as the words. So finally we end up learning the vector representations of our attributes. For instance, this particular t-shirt might have, say, color green or brand XYZ, or say neck polo, sleeves half, so something like that. So I learned the vector representation for our attributes. I learned the vector representation for our styles. I can learn the vector representation of my sessions or end up with the vector representation of a user also, right? So that's what I'll be just discussing, like how do we actually proceed with that, right? So as I've already described, consider a session, right? It is a sequence of styles, right? You take each of the style in the session and encode by its constituent attributes, right? So for instance, a user browse, say, 3 to 4 styles, you take each of the style and encode into its attributes, right? And I'll have millions of sessions. For instance, if I try to run the model on, say, on say, men t-shirts, I'll end up with, say, 2 to 3 million of sessions and in past 5 to 6 months. So and I'll try to train a word-to-vec model on that sort of a corpus. So what I end up with is I learn a vector representation of each of the attributes, right? So for instance, I can say brand Nike is this. I learn a 100-dimensional embedding for that. So brand Nike will have this sort of a vector. Now, if you aggregate those, I'll end up with the vector of a style, right? Because a style is composed of attributes. I have the vector of each of the attributes. I can end up learning the vector representation of the style. Now again, a session is composed of styles. I have the vector representation of each of the style. You aggregate to get a vector representation of the sessions. Now, from where do we get the context which Deepak has been talking, a shoe falling into multiple contexts? So instead of performing the clustering on a style level, what we decided was to cluster on a session level, right? So consider that shoe, like which Deepak showed on the first slide. So that shoe probably might have fallen into 2 sort of sessions, right? One, the functional need, and one could be the physical needs. Now, when I perform the clustering on a session level, it's quite likely that those sort of 2 types of groups of sessions will fall into 2 different clusters. So automatically, a style has now fallen into 2 different clusters, right? And now I'll probably show you in some time from now that we can predict which sort of product group is a user interested in. So I'll be using the words product group, context, cluster. So I'll be using all those words interchangeably, right? So before performing the clustering, we need to define some sort of a coherency measure in a session. You can't just give all sort of a noisy sessions to the clustering algorithm. So the way I define the coherency score is I take this, say for instance, I have 4 styles, right? I take the centroid of those 4 styles, and I find the cosine similarity of that style with of that centroid with all the 4 styles, and I take the minimum of those, right? So just assume those styles, were coherent in nature. That session was quite coherent. So the centroid the minimum distance would be quite low. So here we can say that the session is quite coherent. Otherwise, it's non-coherent. So we just take some sort of a threshold of, say, 0.8 or 0.9 similarity, and we just sort of perform clustering on those sessions. And a style automatically goes into multiple contexts, right? So on an average, our style in the catalog, say, this is for men t-shirts at Myntra. So each style belongs to 2.67 product groups on an average. So now can we predict those product groups real time? So we did some sort of an offline experiment. We took the user sessions. We took the first n-1 styles, what the user has been browsing. We took the product groups of the first n-1 styles and tried to predict what essentially the user will be doing the next, right? And of course, this sort of an experiment should be done on, as a function of coherency score, because it's quite likely that we'll be performing well for coherent sessions, but might not have a good accuracy for the noisy sessions. So that's the graph which shows that we could predict as close to like 95%. So nth style product groups, we were able to predict 95% of times correctly in the top 3, which I had mentioned on the last slide, right? So, and the worst case is also 70%. This sort of assumes that there is no sort of a context switch in the session. A user might start off with a shirt and end up buying with a t-shirt. And let me just give you a metric at Myntra, this sort of impulsive purchasing and impulsive browsing happens at least 40% of the times. So this sort of an assumption is but that was the assumption in this sort of an experiment, that the user does not, changes its context. But yes, we chose all the sessions in the experiment, and we have reported the scores as the accuracy as a function of coherency score, right? So now I'll just discuss few results, right? So attribute-based similarity. So I had all my attribute vectors now. Brand, Nike, cleated shoes, color green, and all that stuff. So for instance, if I take brand replay, now if you see the closest attribute to it, I'm getting MRP greater than 10K, right? So that essentially means that, like, and some sort of the brands which are, similar to it, brands Scotch and Soda, CK, Guess, and Anthony Morato and stuff, right? So this sort of things you can use for, in personalization. For instance, like if I buy Nike, what else can I show you, right? So you can sort of have some sort of an exploration on a brand level rather than exploiting every time. So this can be one of your inputs into your personalization algorithm for that matter, right? And maybe cleats fixed. In the last example, you see color orange and fluorescent green to be quite close to cleats fixed. So, this sort of tells, for instance, if I want to tell what this brand stands for, right? So you can use that. For instance, we have our own brand, Raspberry. So what does it stand for? Now, if I try to find the attributes which are quite similar to brand Raspberry, I would essentially find, things like it's mostly in the range of 1,000 to 1,500, and it mostly makes, polka dresses and stuff. So that's how you can, have what a particular brand essentially stands for. And again, the beauty of those vectors, which initially I was talking about that Flipkart CEO example. So you can map that example in our domain also, right? So for instance, you take the vector of brand Nike plus upper material mesh, right? You'll have one vector. Then you have the vectors of all the styles also. You take the dot products and find out what are the similar styles to that sort of a query. So these sort of attributes can power your search algorithms also. So this, is a motivation behind the semantic search and all, right? So what if I, subtract the color black? And, this color black doesn't really mean color black. It also means, various other colors which are semantically close to color blacks, is sort of a dark gray color and all. It would, subtract all those colors and end up with those styles which I've shown in figure. I've just taken these two figures directly from the paper. Right, and again, given a style, what are the similar styles? So given that Brooks Brothers t-shirts, I end up with these t-shirts. Then given a session, what are the similar sessions? So essentially, since I told I have the vectors for each of them, so you can just keep taking the dot products and find out what sort of similarity works out for us, right? So I just took one such session of superheroes, and I get these two similar sessions with me, right? Right, so, and last thing, so given a style, what are the various product groups it has membership into? So for instance, I take this sort of a t-shirt, right, and it falls into these two contexts, right? So how do I define a context now? Context is a product group, as I already mentioned, right? So you take a product group, you take the centroid of that product group, you have the vector now, and you have the vector of all the attributes. So again, you can clearly tag each of your product groups by the attributes, which describe that product group, right? So I just described those sort of product groups, and when you visually also see, you sort of find some sort of differences between the two contexts. It has actually this sort of a G-Star t-shirt, which I was showing you in the two contexts, right? So context one has more affinity towards round neck t-shirts. So this sort of thing you can also see from the tags which I've shown you. If you see the context one, you see neck _ round _ neck, right? So this attribute is very similar to the context one, right? Context one's centroid essentially, right? So this things, and context two is more coherent in terms of MRP bands. You see in the context two, you will often find MRP bands coming up in the similarity notion. Right? And again, a few more differences I've talked about, right? All t-shirts in context one are short sleeves, while context two has both long and short sleeves, right? So this is how a style can essentially fall into multiple clusters, right? So, just concluding what we have sort of discussed, we tried using word2vec to embed each of our attributes, styles, and sessions into a higher dimensional space, where we can sort of take dot products and just find out how similarity works. We also demonstrated, how you can, use them into your into your personalization or sort of your search algorithms, right? So that's it. Thank you. Any questions?
Sure. We have 5 minutes for questions.
Hi, I'm Pradeep from Yorfit. So I have two questions. One is regarding the session independence. So basically, you say each session, like within a session, you get a lot of attributes. Like okay, but like how does the session independence impact these numbers?
What would you
I
define
mean,
session?
user comes to the website
Ah.
and does I mean a lot of queries and all. That's one session, right?
So we look at the product, so the session of how we define a model is all the products in which he actually looked at the PDP page or the product display page. So only those products kind of constitute the section. So eventually so ultimately there's a lot of noise and a lot of signals, right? So you kind of remove the noise. One way to do it is just look at the products in which he actually viewed. So not just the listing, from a listing he'll click and go into a product. So all the products on which the user expressed a little bit intent defines the session on which, defines the session on which we model the data about. Right.
So, I mean, how does it impact the accuracy numbers? Like,
Ah,
basically,
so-
I see that there is an assumption on independence when user comes again. But suppose in the previous session he didn't buy the product,
Sure.
and next session he comes again, searches for the same product. So, essentially, those two sessions are same, right?
Sure.
Right. So, but here, I mean, I see that each session is an independent document.
Yes.
So, I should have impacted in
Well,
accuracy
no, so,
numbers.
so what we're really modeling is within a session, if I have observed some amount of coherency, can I recommend the next, can I almost preempt the navigation? Can I suggest the next style he should recommend, right? It's really not worried about interdependency of two sessions, right? It's just saying, look, within a session, if I've seen, if he has given me cohesive signals of 3 or 4 PDPs of product display pages, then can I recommend the fourth, fifth? So it's not really talking about independence per se. Yeah, the sessions every record is considered independent. So, but I don't think that impacts the,
Yeah,
the
it won't impact
problem.
the accuracy at all.
Yeah.
It's just the coherency or the intent measure in the session which would rather affect the numbers.
Okay. So once I have the embeddings for all attributes, how do you combine it to a session vector?
So
Like-
you can just take the centroid of those to get the style vector, right? This style has some attributes, color green and brand XYZ, right? And you have the vector representation of each of the words. You just take the centroid of that to get the style vector, and session is made up of style clicks, right? As he
So
mentioned, right?
did you directly arrive at the centroid, or you just, I mean, through various experiments like taking the average or?
We just tried out with the concatenation and the average approach.
Okay. Thanks.
Thank you.
How do you take the user vector also, like user preferences, like for two users having the same browsing, if they are viewing the same products in a session,
Yeah.
The fifth product, like if they are viewing the 4 products and the fifth product would be the same for both the users, or did you also play with the user vector?
No, so as of now, it's just session aware. It's not user aware. In terms of recommendation, it's not taking the user signal at all. But it's pretty much relying on the sequence of styles observed in a session to define what is the next.
And
next
also,
thing.
what all types of like attributes did you take to document? Like one was the product type.
So all brand, MRP, all the style attributes, and even
Even we chose title and description of the style, and we just extracted out the various nouns and did some sort of a cleansing task on top of those title and the
and you can put in as much attributes in there.
But yes, we did not take the image attributes as such. So we are thinking to incorporate image features into our approach, but till now it was just all sort of the textual attributes which we already had.
Okay, yeah, thank you. Cool. Any other questions?
There's one last question that we can take.
So in these attributes, do you have a precedence? Is it like style takes precedence or the MRPs? How do you structure it?
Yeah, so that was essentially that's the beauty of this approach. You need not weigh those sort of the attributes. The model essentially, I mean, you can say, predicting fabric polyester given a center word as color green doesn't really make sense, but this sort of thing works out for us. We need not have, we need not give manual weights to the attributes.
I think that was also the motivation, right? To begin with, I don't want to predefine which is more important, right? That was the fund. I think the first slide was telling us the motivation of this approach, right? Which attribute is more important? Let the session tell me which attributes are more important in the context of the session.
Right. So you don't go based on first visual and then.
Yeah, no. Just everything is thrown into it as of equal importance in some sense.
Okay. Great.
Cool. Thank you.
Thank you. You can connect with them offline.
Thank you.
Thank you so much, Deepak and Sagar.